We started talking about addition of fractions by talking about ordering a pizza cut into 6 equal portions. And this is what we did. We did 1/6, which is one slice. And then 1/6 is again another slice. So that's going to be 2/6 of the pizza, right? Because you're eating two slices out of the 6 total. 2/6, 1/6 plus 1/6, 1 plus 1 is 2, and out of the total 6 slices. That's how the addition of fractions work. But this 1/6 plus 1/6 is the same thing as repeated addition, which is just multiplication. So 1/6 plus 1/6 is 2 times 1/6, and we get 2/6. That's still the same answer. You expect that as the answer. So how does this multiplication of between fractions work? From what I've written here, it looks like all I've done is I just multiplied 2 and 1 to make 2/6 here. But that's not quite exactly what we're doing there. So let's look at this example here, which are what you normally think of as fractions. We're going to start off with our whole unit, which is just going to be a box, and then we're going to cut this thing in half, just going straight down, and that gives us 1/2, which we're going to show here in blue. That's 1/2. Now, instead of looking down this way, top down, we're going to look this way, and I'm going to cut it into fourths. So kind of ignore the blue portion for a moment, and then if we cut this into fourths, it'll be here. Now we have equal fourth portions there. That's what you can see here. And 3/4 is going to be the 3 yellow, and 1 remains not shaded in yellow. Now, when you're going to multiply these two things, all you're going to do is you're going to look for the overlap, which is going to be these portions here. And that's what I've shown here in green. Just these portions. We have 3 portions. And when you look at the total thing that's been cut up, right, we have 8 total. We have 1, 2, 3, 4, 5, 6, 7, 8. There's 8 total now, and there's 3 of the 8 that's shaded. So the answer here is 3/8. And this is where the true algorithm shows up, because if you look here, right, 1 times 3 is 3, 2 times 4 is 8. That's how you multiply fractions. You go straight across the numerators and straight across the denominators. So for 2 times 1/6, we're going to write 2 as a fraction. So 2 becomes 2/1, and then go straight across the numerators, straight across the denominators. 2 times 1 is 2. 1 times 6 is 6. Of course, 2/6 reduces down to 1/3. That's the exact same answer we got when we added 1/6 and 1/6. Okay, multiplying fractions is very easy to do. 2 times 3 is 3. 4 times 2 is 8. This is what I had shown before. There's 3/8. Here, right? 4/1. 5 times 4 is 20. 8 times 1 is 8. Now, in this case, we have to reduce. 20 divided by, we can divide top and bottom by 2. It's going to give 10/4. We can divide this by 2 again to give 5/2. That's an improper fraction, so the mixed number we get is 2.5. Now, in this case, we can actually, I can show you a technique that helps with multiplication of fractions, and that is what's called cross-canceling, or reducing before you do the multiplication. Here, I can actually divide, because I'm multiplying, I can actually reduce the 4 and the 8. 4 divided by 4 is 1, and 8 divided by 4 is 2. And you can see here, now if I go straight across, 5 times 1 is 5. 2 times 1 is 2. So I've done this preliminary step before doing the multiplication, and that took care of these 2 steps right off the bat, and it got me directly to this spot. If you can do that, if you can cross-cancel, do so. It's going to make the numbers smaller and easier to work with. You can multiply mixed numbers. There's actually a diagram way of showing that, but it just takes longer to do than working with the improper fractions. So I highly recommend just change these to improper fractions. 5 times 2 is 10, plus 1 is 11. You get 11/5. 9 times 3 is 27, plus 1 is 28/9. I can't cross cancel. There's nothing on top. 11 and 9 can't reduce. 28 and 5 can't reduce. So I'm just going to go straight across the numerators, straight across the denominators. 11 times 28. I'm going to do this on a calculator because I think it's Probably not too hard to do in the head, but let's just do it like this. 5 times 9 is 45. And 45 can go into 308. I'm just going to do that like calculator 6 times evenly. 6 times 45 is 270. So 308 minus 270 is 38. I don't believe there's any way of reducing that. So that's our answer there. Okay, for this one, I can cross cancel. There's lots of things I can reduce by. I can reduce 6 and 12, I can reduce 14 and 24, or I can go across the multiplication sign. 6 and 24 can divide by 6. 6 divided by 6 is 1. 24 divided by 6 is 6. 12 divided by 2 is 6. And 14 divided by 2 is 7. So I have 1, 7, 6, and 6. Multiplying straight across, I get 7. 1 times 7 is 7. 6 times 6 is 36. And then I don't have to reduce it all because I reduced everything as far as I could initially. Okay, when you have a string of multiplications together, you can, of course, take it step by step. But what you're going to end up doing is just multiplying everything through on top and bottom. That means you can actually cross cancel across everything that's multiplying together. Like I could reduce 3 here and the 3 here. I could also reduce the 2 here, and 4 divided by 2 is 2 there. And when I'm multiplying, I can go 1 times 1 times 1, that's 1. 1 times 3 is 3, times 2 is 6. Or just multiply straight across, right? If I instead went 1 times 2 times 3, I would have gotten 6, and 3 times 3 times 4, 3 times 3 is 9, times 4 is 36. I can divide top and bottom by 6 to get 1 6 again. You're always going to get the same answer no matter which way you do it, but cross-canceling, like I showed here and here and here, makes it a lot quicker to do the work. Once again, there's no real reason to use mixed numbers when doing the mathematics. I think it's just easier to work with improper fractions. 4 times 1 is 4, plus 1 is 5. 3 times 3 is 9, plus 2 is 11. And 3/5. Okay, I can cross cancel. I'll do it in red here just to make it a little bit clearer. 1 and 1. And I can also reduce by 3 here and 3 here. Okay, that gives me 1 times 11 is 11, times 1 is 11. 4 times 1 is 4, times 1 is 4. 4 can go in 11 twice, with 3 remaining. 2 and 3/4 is my solution there. Now, when you're working with application type problems, the word of typically means multiplication. Like there's many contexts where of means multiplication. You have to be careful though, because sometimes the word of is just needed, is just necessary in the sentence for the, you know, how English works. But like here, if you completed 3/4 of a 20-mile run, how many miles did you run? Well, here I can say I completed 3/4 of 20. 3/4 of 20 is multiplication. I'm going to write 20 as 20 over 1. So all I need to do is reduce, I can reduce this by 4, reduce this one by 4. And that gives me 3 times 5 is 15. 1 times 1 is 1. This, of course, is just 15 miles. 3/4 of 20 miles is 15 miles. Okay, 4/7 of the human body is water weight. How much, about 4/7 is, how much water weight is present in a person weighing 182 pounds? So 4/7 of the human body, or the weight of the human body is what it's saying there. So 4/7 of the weight. Well, the weight's 182. So this is really asking, what is 4/7 of 182? That is 4/7 of 182. That's going to be 182 over 1. Let's see if 7 can go into 182. I'm just going to type it in a calculator. It can. It can go in there evenly. So 7 divided by 7 is 1. 182 divided by 7 is 26. 4 times 26 is going to be 104. 1 times 1 is 1. So we get 104 pounds. That's 4/7 of 182. Okay, finally we have the center to center distance of consecutive holes. That just means holes one after the other. And a metal strip is 3/8 of an inch. What is the total distance from the center of the first and the last hole if there are 11 consecutive holes? So think about it like this. I'm gonna draw a diagram because I can here. So we're gonna have a circle because it's just a round hole, and then another one, another one, another one. So here we have some metal strip with 11 consecutive holes, and we know that the center to center distance, so this point to this point here, the center from this hole to the center of this hole is 3/8 of an inch. Okay, what is the distance from the center of this hole to the center of this hole here? That's what the question is asking. What's that distance? Well, once again, the center distance, right? Here, here. Each one of these things is 3/8. So 3/8, and then 3/8, and so on. All these things are 3/8. And how many of them are there? Well, we can just count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 3/8 plus 3/8 plus 3/8 plus 3/8 plus 3/8. A total of 10 times. But repeated addition is just multiplication. 3/8 times 10. That means 10 over 1. Reduce by 2. Top and bottom. 3 times 5 is 15. 4 times 1 is 4. And writing that, in this case, it's best to write this as a mixed number because it makes more sense, right? 15 over 4 inches doesn't make as much sense as, well, 4 can go to 15 3 times evenly with 3 left over, 3 3/4 of an inch. That makes a lot more sense when we're interpreting this answer.